Okay, so for today, we're going to continue with data visualization with Leafmap. And so we're going to talk about how to visualize vector data, raster data. Last lecture, we already talked about how to visualize some of the points, marker cluster, and you can create those easily just with couple lines code. And today, we're going to continue with doing lines and also polygons and also raster data. So before I get into that, I would like to briefly go over lab 6. So some of you were having issue with some of these data set. And so starting from lab 6, we are dealing with some of the geospatial data set. And some of the data set that are provided, it might be hosted on somewhere, for example, on GitHub. So how do you actually open the data set? And then you can traditional way you will be, for example, I provide this question 1 here, right? I provide this next CDF file. You go here, click, and then you download this one to a computer. But this is not usually not the recommended way. If you're trying to develop some solution, you want to do everything programmatically. You don't want to click the button because user can save the file on this directory, on the other directory, you have no idea. So in your source code, you should try to avoid downloading file manually. So I'm going to show you an easy way where you can download the file easily, and then you can, that solution that you develop should work on your local computer. It should also work if you use Google Colab. So because the file that you downloaded, by manually clicking on that, the file is not accessible on Google Colab. So it's going to show you, the file doesn't exist, because if you click the icon, for example, let me quickly go here and open this one in Google Colab, for example. So how do you determine whether the file is accessible or not? It's on the left side here. If you click this icon, this is so-called the current working directory. So if the file doesn't exist in here, you cannot open it. So the file that I downloaded, for example, earlier, it's on my local computer. This is a server, so that's why they're disconnected. So there's no way you can open the data. So the recommended way would be to download the data. For example, if they say you are using Google Colab, right? So first step here, you definitely need to import, for example, Leafmap. So I'm going to just type here pip install Leafmap and then enter it. So I will let this one finish, but I'm going to show you quickly here locally how are we doing that locally. So probably this is just too big. So let me zoom out a little bit. What is it? Is it control? Okay. So all right, it's pretty quick. It's already done. So now I can actually do it like this. So what you need to do here, you'll be doing something like this. So pay attention. I'm going to just right click, copy link address. So this is the direct URL pointing to the file. So what you can do here is to create a new code block, and then you can just type URL equal to Control V, and then you can just alt enter, create a new code block. So right now you're pointing to this URL rather than manually try to click to download it. Then you can use this function, leafmap dot. Oh, you need to import Leafmap first. So import Leafmap and then alt enter. And then you can use this function Leafmap dot download file. It might take some time for the autocomplete to show up. So download files and then parentheses. Then you can see the help documentation here. So all you need to do is just pass in the URL. That's it. And by default, it's going to download this file. It's going to rename this one with whatever the file name at the end of your URL. But you can customize it if you want to. So for me, for example, okay, I want to use this file name. So you can come here and then say file name equal to double quotes, this one, .nc. Then in here, you can just pass in file name. So what this one is doing, you can rename the file if needed. So pay attention here, right? Once I click and pay attention to the left side here, it's going to download the file. So this is 149 megabyte. And after it's done, the file is being downloaded to the Google Colab server. So see this one here? You see that? This file is not on a local computer. This file is on the server. But if you run this code block on your local computer, it should also work. Make sense? So this is how you right now, if you access the file, for example, if right now you can open it. So let's say on this question, import X array is XR. And then I'm going to run this one. Then you can use XR to open, for example, dataset. no data array dataset, and double quotes. And now you can just pass in the file name, right? Because the file name is the one I defined, so then it should work. Make sense? So these solutions work both in the cloud and also locally. So for example, if I just copy all these code blocks, copy here, URL, right? And I can just copy this entire code block, come back to Leafmap here, and then I can paste it, import Leafmap, and download this one. You see, it's going to show you it's downloading this file. And then after that, you can do the same thing. I can just import X-array as XR, run it, and then XR.open dataset, file name. Wait for it to finish. Then you should be able to open. So in this way, you don't need to ask the user, okay, click this button, download the file. You can do it for any files. So pretty much any files accessible through HTTP URL, you can use leafmap.download file to download it. If it's a zip file, you will automatically download and then unzip the file. There are other parameters in here. If you hover your mouse, there are a couple other parameters. For example, output quiet, or do you want to overwrite? There are some other parameters, but usually you don't have to deal with that. Just give me the URL. Where do you want to save the file or the output file name? That's it. So you can download any files. So in the future for all the lab assignments, some of the Leafmap function can directly open the files to HTTP URL, but some of the packages might not be able to do that. So if it doesn't work, it's saying the file doesn't exist or blah, blah, then you use this one to download the file to your server, to Google Colab, or to your local computer. Then you can open it. Okay? Any other questions? All right, if not, let's continue. So in the last lecture, we already covered how to visualize geospatial data. So we talk about the raster, the point marker and marker cluster. So today we want to continue here to talk about line and also polygon. So specifically, we're going to deal with, for example, these cable lines, submarine cable lines across the ocean. And so by default, Leafmap is going to visualize that using, for example, blue color. And then when you hover your mouse, you're going to see it's being highlighted as yellow color. But everything here, we can change it so we can customize whatever color that you like. So I'm going to go back to my VS Code here. Okay. And I'm going to scroll down all the way to the vector data. Polyline. Okay. So here, this is the one. And let me unzip, remove this. So take a look, pretty simple, right? So this is why, Leafmap is very easy to use because as you can see, this GeoJSON is also accessible through the HTTP URL. You don't have to download it manually. So Leafmap takes care of that. So if it is a file through HTTP URL, you will download the file and then read it. You can also read the file locally, right? So for example, here, I can do the same thing, just like what we did earlier. For example, this is the file you want to download. So URL equal to this, right? And you can do the same thing. I can just leafmap.download file, right? So if this is something you want, you can certainly do that. So this is the URL, this is the output file name, right? And you will run it. You see, it's being downloaded. Sometimes if it is too crowded, you can make it quiet equal to true. Then it will not show you anything. But it's useful if you're downloading a large file, you want to show the progress. So this one here, if you execute it, you see it's already exists. If it's going to ask you, do you want to overwrite? So if you want to overwrite, you can say overwrite equal to true, all right? And then Control Enter. Now it should download again. So it's going to return this file path to you. And then from here, then I can just say data equal to cable.geojson, right? So if we down the HTTP URL, right now, this file is pointing to your local computer. So the file exists under our file path in here. So that's why we can also do it this way. Okay, make sense? So you can use Leafmap to visualize files locally or from a remote server through HTTP URL. But definitely the file need to be accessible. So for example, if you have a file on Google Drive and it's like private, then you cannot do that, okay? So what you can do here is always copy this URL, and then you open, for example, Chrome, and then open the incognito mode, then you paste the URL. Once you hit enter, if it pop up asking you to download the file, that means you're good to go. If it doesn't, and then ask you to log in or something, then your program will not have access. You won't be able to download the file. So this is something that you need to be aware. So this is how you visualize the data using like just add vector, right? So add vector can handle GeoJSON, it can handle shapefile, it can handle all kind of data format. And so by default, as I mentioned, it's going to be render using blue color. And if you hover your mouse, you're going to show you basically the property, the attribute table of each individual line. So you will see here, and the color here, you can customize it. Everything you can customize. So if you go back to this one, add vector here, hover your mouse, you're going to see these properties. And there's a style, also a hover style, and there's also a style callback. So these three parameters are the one that's going to control the visualization of the file, right? So it seems, for example, right now it's blue color. They say you don't like blue color. I want it to be black color. I want it to be thicker. I want it to be something else. You can change it. So let me show you, like by default, it's going to be, the color is going to be none. That means you don't say anything. So let me show you how we can change it to something else. So I can say set a style equal to, a style basically is a dictionary. So this all inherit from leaflet. So leaflet has no style. If you really want to run it, you can just type leaflet, for example, polyline style. You should be able to find the, for example, leaflet polyline. Not really polyline, I think it's GeoJSON. So you can certainly, but they're very much similar. So you can see the some of these things in here: style, stroke, weight, opacity, line, blah blah blah, fill color. So these are things you can customize of the style. So for example, if you want to change the color, you can use this one. There's a color parameter, and also there's a weight. The weight means the thickness of the line. So they say, okay, right now I want to change it to maybe red color, and I want to change the thickness from, by default it's only 1. I just want to change it to 3. So what we can do here, you define a dictionary. Okay, so this dictionary is the one that's going to control the style, and the name of the key is, you can use any of the keys in here, right? So the first one, for example, I want to change the color, then it will be color. Oops. And then colon. Perfect. I like it. I don't need to type. Probably not the fill opacity, because this is line. The fill opacity only applies to polygon. So how about this? Okay, line color rate, weight 3. Basically, the thickness is 3 pixels. So once you define the style, then you need to pass in inside the add vector function, right? So there's a style parameter in here. So what we can do here, just style equal to style. That's it. I don't think there's anything else you need to do. Perfect. Take a look. And easy and PG, right? Just set the style, whatever style you want. And if I hover my mouse, you see here it's still blue color, yellow color, right? And right now the thickness is probably just way too much. So we can change it maybe just to 2 and run it. Great. So now it's a little bit better. You can change this color to anything. So just name of the color, or you can use hex color code. So the pound sign, hashtag, and then RGB, okay? 6 digits, red, green, and blue. So for example, let's say, okay, I want to change it to blue color. What's the hex code for blue color? Okay, RGB, right? So if it is blue, that means it's hex color code, so it's FF, right? So it's no red, no green, all yellow, all blue, right? So it'd be, what's the hex code for blue color? You need to know that, okay, if you're doing program. So it's 0, 0. So this one, the first two is red, right? Green, no green, right? 0, 0, okay? And then FF. So that means blue color. If you run it, you should get blue color like this. So it can be any color. So you don't have to know that. So for example, I'm gonna ask ChatGPT like hex code for maybe pink color. All right. So the FF, because pink is like close to red, right? So you see red is FF. So, and I don't need to worry about it. Just here, Control C, Control V, and let's see if it is pink color. Perfect, pink color. So you can customize to any color you like, and it's very easy. So all you need to just define the style, then it should be it. So here, I'm going to change it maybe to black color. If you use just the name of the color, don't put the hashtag at the beginning. Okay, hashtag is only for hex color code. Then you need to put a hashtag. You can give a name, then you don't need the hex color. So now it's black color. So here you will see good. So it's this is yellow color, but the same thing you can change it. So for example, I can also there's another parameter here called style callback. So it's this one. Oh no, the hover style. So that means by default this is what is being rendered. So right now it's black color, thickness 2. Maybe let me change to 1. Make it easier. And so if you want to change it to something else, I can just define another dictionary. So it will be hover style equal to I think I can change the color. For example, here color, oops, color equal to red, and then maybe the weight. Okay, weight equal to 2. You need to double quote it. So same thing in here. I can just change it to hover style equal to hover style, comma. Make sense? And then I'm going to run it. So this time it's going to be rendered by black color, but the hover style controls when you hover your mouse hover over that feature. So what should be the color right now if I hover over it? You see it? Now it's red color, and the thickness 2. If you think it's too little, I can change it to 5. One again. Now it's much thicker, right? Number 5. So if I give you a polygon or any vector data, let's line geometry, now you should be able to customize it, right? So all you need to do is create a map, set the style. If you don't set it, it's going to use the default style. And then you can say, okay, I want the style to be this. And when you hover my feature, I'm going to use the hover style. And then that's it. So there's another one here called inform mode. So inform mode basically means when you want to hover your feature, is going to the low right here, it's going to show you this one. Or you can on click, you only show it when you click on it. Or you don't want to show anything. So let's change it to on click. So right now, when you hover a mouse, it's not going to do anything. It's kind of a minimizing here, but if I click on that, you see it's coming up. You can hide it. Sometimes the reason you want to do this is because it might be too much. You have too many features, you don't want it. So I can just click here again. Oh, you need to unhide it. So now if I click this one, you see it's been changing. So this is so-called the informal. But if you don't want it, you can just set it to none. Then it won't show you anything. So right now it'll be just the map. There's no pop-up showing up in here. Okay. So this is how you can easily visualize any vector data that is line geometry. Questions? Besides that, you can do it a little bit even more advanced. So right now, for example, for this file, let me remove this one. By default, it's going to use the on hover mode. So for example, this is a line geometry. So if you see the attribute, there's actually a column that has the color. So that means you can use some of the attributes from the data to color it, because this one here has the color. So for example, for each line, it shows you the color. You have this color attribute. So you don't, sometimes you don't, because right now for all the lines, it's using the same color, right? But you can change the color to have a predefined color. So this is what this one is about. And let's take a look at it first. You see, this one looks a lot more colorful. Does it look better than the previous one? So basically different color, different style, maybe different continent, different scale, different things. And this is very much common. And so what we do here, we use the style callback. Style callback basically means that it's a callback function. Callback means when you have basically for every line, it's going to read something, it's going to do something differently for every line. And what we're doing here is to acquire the attribute because the line has the property and it has a color. And I'm going to get the color from the line. So basically what we are doing here, for each line in here, there's a color property. So I'm going to get the color from this line and then use this color to render it, right? And once you're passing this callback function, then this one is using a so-called lambda function. Lambda means it's basically just a anonymous function that basically for every feature, I'm going to set a color, and the color depends on the color property of that line. So the existing attribute, and I'm going to set the weight equal to 1, then everything else pretty much remain the same, right? So except that right now we have the callback function. So this is how it's being rendered in here. You can also change it. For example, right now the weight is only 1. I can change it to 2. So you should have a much interesting. Probably something is wrong. I need to fix it. This might be a bug. It's supposed to change the weight. If it doesn't, that means there's a bug in Leafmap. Okay, then it's probably a bug. I need to look into the source code. Ideally, it should be changing the weight. Maybe there's something being overwritten in the source code. Anyway, so this is how you visualize line features. Just using the add vector function. And depending on what you want, if you want the style, you change the style. If you want the color, you can add a color. You can change the hover style. You can change the callback style if you want to. Any questions? So try it with any other line dataset. It can be road, network, it can be street, it can be hiking trail, it can be anything. So as long as it's the line, it's a GeoJSON or it's a shape file, then you can do it. Maybe I can show you. Oh, anyway, I'll show you the other examples later. So next, let's talk about polygon. So it's very much the same. You can pass in the URL. So this is again just a GeoJSON. And we are just adding the vector data and then just URL, give a layer name, and then whether or not you want to zoom to the layer. If it doesn't, by default, sometimes if the map is zooming to the global scale, it might be too small. So because by default, it doesn't zoom in. And if you run this one, it will show you the global map. So it's too tiny. And unless you already know where it is, otherwise it might be difficult to find it out. So that's why you usually want to set the zoom to layer to true, so they automatically zoom to the region of interest rather than showing you the global map. So this one shows you the polygon, right? And similarly, take a look at this. So you can set the style. So by right now, by default, the polygon are being rendered using blue color. And also there's some kind of a transparency inside the polygon. So right now, if I give you a task, okay, so for the midterm exam, I'm going to ask you, give you this vector data, and then just render it using just the outline. Don't fill any color in it. Okay, so can you do that? So what do you think? What we need to add? Similar to the line, right? Except right now we are dealing with fill opacity, fill color, fill something else. So if you see this one here, the polygon probably, and right, the fill color, fill opacity, whether or not to fill, and also the color, the outline color, the weight or something like that. So let's do it here. Same thing, just like the line. Now we're going to set the style, right? So the style controls when the map is being loaded, what it's going to look like. The hover style is when your mouse moves around, you're going to change the style. So by default, we should be handling the style in here and parentheses. So they say I want to render the buildings in red color outline. So what do we do? UV color, right? Yes. And then colon, and then red. All right. Anything else? Okay, perfect. I don't need to write. So fill color. They say the fill color it can be red, but if you want to make it like transparent, it doesn't really matter what color you put in here. So what you need to do here is just put this one to 0. That means there's no color being filled. Even if you set the fill color, you don't have to do it in here. But the fill opacity, if it's 0, that means you're just showing it the outline. So this one. Oh, by the way, I forgot to say here, style equal to style, and then run it. See? So now we are having the polygon, right? There's no fill color. You see the fill color? No. It's only when I hover my mouse, it changes the color to yellow. But the color itself is only like just doing like this. So I can change the color, maybe add this one here, change it to Google Satellite. So now you can see the building footprint like over there on top of the satellite data layer. So these are all the polygon, the building footprints. If you want some kind of color, certainly you can do that, right? I can change this color. It doesn't have to be red. I can change it to blue, and then I can say the opacity maybe to 0.2. You can customize to whatever way you want, right? So now you see some light blue inside, and when you hover a mouse, it becomes transparent. You can change the color. So similarly, you can change the hover, the style. I can do it hover style equal to fill color equal to green, fill opacity to 0.7. Okay. Hover style equal to hover style, and like that. Control Enter. So now take a look. You see, it's green color now. Yes. And the transparency is increased to from 0.1 to 0.7. You can make it fully opaque. So then you're going to change to 1. That means 100% is going to be fully opaque. All right. So now hover my mouse. This is it fully opaque now? So take your time to customize. You see here 1, 2, 3, 4, 5. 5 lines of code. Then you can customize to visualize any vector data, raster data pretty easily. So they're using the add vector. This one, like I said, can handle all kind of vector data format. It can be GeoJSON, it can be ShapeFile, it can be GeoParquet. It can be any vector data format that's supported by GeoPandas. So the next example I'm going to show you here is actually using the GeoPandas example. So we can use import the GeoPandas. We have already covered this one in the previous lecture. So similarly, for example, I'm going to open the Las Vegas example. And I'm going to use the read file and then return it as a geodata frame. Then I show you the first 5 rows of the geodata frame. So GeoPandas has this explore function that allows you to visualize the polygon directly. So in this way, you don't need to use Leafmap. But the downside is that it's a little bit difficult to change the style. Of course, you can, but this is using Folium. So Folium is for visualization. You cannot actually get user input and then return it to data for the data processing. But this is a nice function that you might want to use if you need to visualize some data directly. And so similar here, Leafmap has this add GDF, so add geodata frame. And similarly, you can change the style, you can change all kinds of things, right? So just like the add vector function, this one allows you, for example, the building, right? Similarly, I have this building footprint here. And so behind is the satellite base map. So I overlaid the building polygons on top of the satellite base map. And the default color here is the red. Fill color is red. Opacity is 0.1, basically 10%. And the weight is 2. So you can change it to other color. For example, I change it to blue color. I can change the opacity to maybe 5. And if you run again, you see, now I have this blue color and then red outline. And so you should be able to use this one to color to any style that you want. Just add the style, add the hover style, and then just passing the parameter into the function. Then you should be good to go. Okay, so any questions? If not, let's continue the next section. So the previous example will show you how to customize the color, but sometimes you want to color the polygon or the geometries based on the attribute inside the data. And so this in GIS, we usually call this choropleth maps. That means you want to create some semantic maps, and so they can showcase the data. And so the data might have some variation, right? The value might be high, might be low. And we have this function here called add data. So this is just one line of code that allows you to add data directly. So let me show you the output first. So we are pointing to this file, and this is basically the countries with population. So let me show you when I hover my mouse. All right, so you can see, for example, the population. So there's an attribute here, POPEXT, right? And the population rank, and then some of the other information. So for example, this one shows you the quantile. So when we create maps, choropleth maps, we have different classification scheme. So you can use quantile, you can use equal interval, you can use all kind of other classification schemes. So quantile means, they say we divide the global, all the countries into, they say we have 200 countries, and we're going to divide them into, let's say, 4 or 5 groups, for example. So quantile, for example, you're going to do like 25%, 50%, 75%, and also 100%. So you can easily classify them into different groups. So this one here right now looks like balanced, right? So darker color means higher population. So for example, US, China, Russia, and some other countries. So the lighter color, the smaller the population. So what you can do here is use this add data, and then just tell the program which column you want to use to do the color. So here we're using just the population EST, and then what kind of color map you want to use. Want to use the blue, and also the legend title is basically this one. So by default, it's going to add this legend, different categories onto the map so that you can see. Let me zoom out a little bit. Whoops. Right. So right now you see pretty easy. So this is similar to, for example, in desktop GIS, ArcGIS, QGIS, you load the map and then you want to see some, create some map, nice map that you can showcase the patterns of the data. And this classification schemes here, you can change it. So if you add this one, if you scroll down, you can see the scheme here. So we have couple classifications, for example, equal interval, feature strength, and there are many others here. The other common one might be, for example, natural breaks, and quantiles, percentiles, also standard deviation and mean. So these are some of the common measures you can use. And I can show you, for example, I can Google ArcGIS classification scheme. I believe they have some of those, for example, data classification measures. And it's very much similar. So you can see some of these things in here. Quantile, defined interval, manual interval, geometry, standard deviation. So they are very much similar. So, but we can do it programmatically. And this one, I can try, for example, different measures. So let's say I want the, what else? For example, I want the natural breaks. So I can Control C. Then I can change this one to natural breaks. Run it. Do you notice the difference? So it's different category, different classification scheme. So the color is going to be very, very different. So the natural break basically going to find the breaking points between groups. And so right now it's very different. So the quantile is more evenly distributed because each group going to have the same number of countries. But right now, the natural break is not. It's going to be find the differences between the absolute number. So that's why it's going to look different. And you can also do equal interval. So this one is even more unevenly distributed because India and China have the largest population. So that's why they are way ahead of everyone else. And they are very dark color. All the other countries kind of a light blue, lighter color. And except the US and other countries are pretty much like in compare to the absolute population, they are only a tiny fraction. So that's why they are way below the average of those countries. So this is how you can use to create choropleth maps using just the add data. So all you need to just provide the file either through HTTP URL or the file on your local computer, and then just add data. Then specify how you want to do the classification. And you can set a title. So for example, the legend, the color map. For example, if this is not something you like, you can change the color map to any map probably color map. So I can change it, for example, to maybe, let me see if there's a called green. Okay. Maybe let me try this one. It'll be a little bit better color. See, green. Right. Pretty cool, right? One line of code. So now you don't have to manually to create those. I can change it to maybe to terrain. Right. Very colorful. I can change it to maybe cool, warm. Okay. So it's very, very easy to do. Just one line of code. And this can give you precise control about your data, how you want your visualization to look like. And so those are covering the most commonly used data format: vector data, GeoJSON, shape file, or GeoPandas. The next one is called GeoParquet. So have you heard about GeoParquet? No? So it's a new data format that's called column-based data. And this is particularly useful in the cloud environment, because when we are querying the data, most of the time we are querying by column. But for example, the country, for example, population. If you're trying to select, let's say, population, the country is with population with more than 100 million, right? So you're selecting by column, you're selecting by attribute. In that case, all you care about is the column. You're not caring about other columns, about rows. It doesn't really matter. So column-based, it's called columnar format. It's very useful doing data retrieval in the cloud, because you don't need to download the entire data set. You can retrieve the data very quickly by using a certain column. And GeoPandas can also read the data GeoParquet. So this one here, I have this example. I have this file here, the cities, and we can download the file. So similarly, just like what we're doing here, I download this file to my computer, and then we can use the GeoPandas.read Parquet file, GeoParquet. And after that, it's going to turn that into a geodata frame. So take a look, right? So this is a GeoParquet file, and it has point geometry. So basically, it's the cities around the globe. We have latitude, longitude, and the name, and also the population, something like this. So with the GeoPandas, you can, the geodata frame, then you can use the explore function to basically see the points, for example, here. Right, so these are all the cities around the globe. And if you have your mouse, you should be able to see the pop-up attributes for the data set. Then you can, there are a couple ways you can add the data to the map. You can use the add GDF, or you can use the add points from XY. So let's try this one. Add points from XY basically means this is geodata frame, and because each point has a latitude and longitude in the attribute table. So that means we can construct the vector data based on the latitude and longitude. So, and this one is using IPy leaflet, so it's going to take you a little bit longer because each point is an IPy widget. So it's not as efficient as the GeoPandas. The volume, they just, it's one-way street. So this one can show you the data very, very quickly. This one might take some time. Okay, it's here now. So how many lines of code? Basically, just 3 lines of code. Then you can add the geodata frame. So if you want to, for example, if you want to create if you want to create a marker cluster, then this might be the best, easiest way to do that. So imagine if you have a CSV, you have a pandas data frame, or you have a GeoPandas data frame, and this might be pretty useful. Just add points from X, Y, and then specify the X column and also the Y column, the name of the column. So the X means is longitude, right? Vertical. The Y is horizontal. So Y is latitude, X is longitude. And this column name comes from here, right? So this is the column name. So if the column name means it's something else, then you need to specify it. Sometimes it might be LAT, sometimes it might be LON. So it depends on your data that you are dealing with. But in this case, it's latitude, longitude. And that's why I'm passing in this one here and then to create this marker cluster map. And with just 3 lines of code, you can create a nice map like this easily. If you're trying to do this manually using IPyLeaflet, you have many lines of code need to write. So Leafmap simplify the process for creating interactive maps. So most of the maps can be created and render using just couple lines of code. Super easy to do. Similarly, you can visualize vector data. So there's also Parquet, for example, vector data. This is the wetlands data from the National Wetlands Inventory from the US Fish and Wildlife Service, right? So I have this Parquet file here, and I can also download this one using GeoPandas. And this is going to show you, for example, different wetlands, different types, and also the geometry. Similarly, you can take a look at the coordinate information, the CIS coordinate reference system. So this one shows you, for example, is the corners, elbows, projection. And you can also visualize that. Just use the explore function to visualize the polygon, something like this. So now if you hover your mouse, it's always going to be rendered using the half transparent green color. So now you have the lines, you have polygons all together in the same data layer. And if you want to use Leafmap, then you can do it. Just to use the map.add NWI function. And this one, the nice thing about the Leafmap is because you can render the color. So there's a add NWI function specifically for visualizing national wetlands inventory data. And it's going to color them based on the column. So take a look at this. If you run into any errors with this function, you might want to update your Leafmap package. I think this is the one that I did maybe a week or 2 ago. So if you have already installed this one long time ago, if you show any errors, then try to update this one. Just pip install hyphen uppercase U and then Leafmap. You should be able to update it. So take a look at this, right? This is just the wetlands inventory data, and it has been colored automatically using the function. So just add that NWI, passing the geodata frame, and tell that which column name. So sometimes it can be wetland underscore type. If it is a swap file, it might be just underscore TY. So that's why you might need to specify this one, and then whether or not you want to zoom to the data layer. So take a look at on the right here. So we have this nice legend created automatically based on the data set. So if you hover my mouse, you will see it becomes transparent. So this is pretty convenient. So you can add data set from pretty much anywhere. And you can visualize that on top of the base map. Any questions? So I will show you how to render different vector data format, okay? GeoJSON swap file, GeoParquet, GeoPackage, or any vector data format supported by GeoPandas. So the next one I'm going to cover is called PMTiles. PMTiles is a new vector data format that is super useful for visualizing large vector data set. And I think it's maybe only 2 years old, so you might not have heard about it. But if you need to create some web applications that deal with large amount of data, and you want to create some application for user to see, this is probably something you might want to consider. because it's very powerful and it's very fast. And all you need is just put the file somewhere and then make it accessible through HTTP URL. Then user can pull the data. So this is kind of like you can host the data somewhere on the server, and you can create map applications to pull in the data layer. Just like, for example, you're visualizing Google Map, Google Satellite data layer. So, for example, I have this file here. It's going to HTTPS blah 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 and then .PMTiles. Okay. You want to learn more, you can go to the website. This is called Overture Maps. It's an open source and it's a very popular one. You definitely want to be familiar because it's used a lot in some of the open access data, especially large vector data set. So Leafmap has this PMTiles. You can read the metadata from PMTiles. So if I run this one, you will see it's going to print out what kind of data layers within this. So PMTiles allow you to put multiple data layers within a single file. So it's just a single file. You can have lines, you can have polygons, you can have points, you can have multiple data layers together within the same single file. And inside, basically, it's doing kind of a tiling, different zoom level. You're going to have different tiles. One advantage is it allows you to customize. So it's not static. You can change the style. You can customize style to whatever way you want. So first, let's look at just the metadata. So PMTiles metadata. You can see what kind of data layers inside. You can also see the bounding boxes. So this just gives you some basic information. So next, this just to try to visualize the data. So take a look at this. This is nothing fancy. It's just like you see here, when you zoom in and zoom out, you can see the data layers popping up, polygon, lines, and when you zoom in, you're going to see more details. And this is the magic of using PMTiles because it handles all the different zoom level and also the aggregation of different data layer, right? So if you zoom in, you can continue to see it's getting better in here. And so the style is being controlled by here, right? So this one is pretty much, you don't need to change it. All you need to do is just control this one, the buildings, and then the color you want to use, the rows, but there are also other data layers. So the data layer come from here. Right now, we are not rendering all the data layer. We are only rendering just 2 data layer, but you can choose to render all the data layer if you want to. So for example, for this one right now, we're using the steel blue color. You can change it to something else. I can change it, for example, to maybe green color. And then run it. You see it? It's green color. So this is nice because most of the vector data is hosting on the HTTP URL. When you're doing the customization, you might need to download the file or you might need to render it in advance. But PMTiles allow you to request the visualization on demand, and you can do the coloring on the fly so that you don't have to store the style in advance. And this is super cool. So you can, basically anyone can use those data layer. You can customize it to your liking. And you can change the color, you can change the signage, you can change different visualization data layer. It's super cool. So you might want to try out this one. And as I mentioned, one of the biggest advantages of using this is because it can handle large vector data set. So for this one, I'm going to show you. This is so-called building footprint data set. So this one is from the stored under the source cooperative. So look at this data set. And if you go to the browse, look at this file. It's called PMTiles. And so this one here, Google M cross, which one here? Let me double check. Google MS building footprint. So it's this one. All right. How big is the data set? Can you see the number? How big it is? So this file that we are we are trying to access is 193 gigabyte. Can you handle it on your laptop? It's going to take you a while to download. And this is the power of using so-called cloud native solution. So what you need to put a large file on the server, and the user can just put the data on the fly, and it doesn't download the entire file. It's going to be the HTTP range request. So depends on the zoom level, depends on the area. It's only downloading a small subset. So this is how we actually visualize this one. This is almost 200 gigabyte file. And look at this. Pretty simple. We create a map, we add a base map, we set the style we want, and we just call the add PMTiles function. Give it a name, give the style, and let's see. You can do it. All right, so this is just the one, and then you can zoom in. You should be able to see the green color popping up. Again, this is almost 200 gigabyte. There's no way you can open the 200 gigabyte file directly on computer, but if you zoom in, so when you're zooming in, it's going to downloading the tile and more wide scale tiles to your computer. Take a look. Super nice. So you can turn the layer on and off. Oh, so this one doesn't work yet. It's kind of still waiting for iPyLeaflet to improve the functionality so that we can turn the layer on and off. Right now, once you add the data layer, you cannot turn it off, but you can control something in here. So what this one is about, look at this. We can fill the color so you can change it, right? So the file is static, but the visualization can be customized. So how do we change this one to red color? You will see this one is slightly different. So this one using Matplotlib. We cover Matplotlib next week about 3D visualization, but they're very much similar. So the fill color, right? If you want to change to red color, I can just maybe red color. I can change the opacity. So if you don't need to fill color, I can change it to 0. That means we're just going to show the outline of the polygon. So run this one again and zoom in. Okay, wait. Oh, the polygon, you do need to have the color. Otherwise, this is using Matplotlib, so it's different. So it's using a polygon. So if you don't have the color, it will not show up. So I need to change it maybe to 0.3. You can render it as line, but you need to add 2 separate polygons. So now you should be able to see, the line polygons. Oops. Where is it? It might take some time to load up because it's not instant, but see. So now I have this render using red color, view opacity, so kind of half transparent. So we are rendering this one at the global scale. So the data, the building footprint is at the global scale, so you can actually visualize anywhere that you like. How about take a look at this one. For example, let's look at UT campus. So Knoxville. And where's the football stadium? All right, so it's here, right? Is this one? And we are maybe here. Right, so this is our building. Maybe, yeah, can I turn it off? This is way too high resolution. Right? This is the, oh, no, not here. Oh, we're here. Okay, this one. You see there's some like offset because we had, this is the building, this is the Walters building. But again, this is global scale, so you can look at the data for anywhere. It's global. And this is one data source. The other one I'll show you is called Overture Maps data. And this is coming from the Overture Maps Foundation. And so the idea is that they want to create open access data for the entire globe. So it can be building, it can be roads, it can be all kind of data. And it's all open access. So you can download the data for free. They also provide this data using the so-called PMTiles. And this one is even much larger. I think it's like, I don't know how big is this data set. It's a couple 100 gigabyte. And we don't need to download the data. We can just render the data on the fly. So let me show you here. I'm going to run this one. So the Overture Maps data, if you want to learn more, you can go to the website. So this is a new initiative, I think, started from last year sometime. And they have produced a lot of data that's very, very useful. You can go to the documentation website. It's going to show you what kind of data set that are available from them. And you can download the data if you want, but they already provide the data in kind of cloud native format so that you don't have to render. You don't have to download, so you can render them on the fly. So for this one specifically, the latest version that they released is September 18th. So it's about a month ago. And this is the PMTiles that they provided. So let me try to download this one, okay? I'm going to click this link. It's going to take me to the download. And I'm not going to download the whole file. I'm just trying to figure out how big is this file. So take a look at this. I'm going to click save. Hope my computer doesn't crash. I'm going to click save. And let's look at this one. How big? 136 gigabyte. My goodness, I don't want to download it. It's just way too much. So this file is 136 gigabyte. And what we're going to do here is to visualize that without having to download it. So the idea is just like you're watching a movie on Netflix. The file can be pretty big with high definition. It can be many gigabytes, but you're just doing the streaming. You're just watching it on the fly. So we are doing the same thing here. We are just going to customize the style to whatever way we want. And then just 4 lines of code. Create the map, add the base map, and then add the PMTiles. Pointing to the URL, set the style, and that's it. So let me run this one. And these 2 examples here. Perfect. So right now for this one is visualizing the building data set. And so what you can control here is this one. The layers, the style. So for this one, we are using basically just the yellow color. And then 40% transparent. We also have the outline color also is yellow. So this is the building footprint, right? You can see here, it's very nice. Of course, some of the buildings, these are new buildings, so it's not covered. But if you zoom in, it's pretty close. So these are all open access data. You can actually download the data if you want to. And it's 136 gigabyte. It's a huge data set. And it's very powerful. So if you hover your mouse, you can see the data layer. You can zoom to any other location. For example, I'm going to not just the US. You can go to the, for example, the UK. You can zoom in. And you will be able to see this polygon right in here. There are some like artifacts in here. Certainly it happens. It's not perfect, but they run those algorithms on like automatically using AI and other like machine learning algorithms. So that's why it's like sometimes you might need to be careful, but it's free. Anyone can use it for any purposes. You don't need a license. It's open access. So it's the best freely available dataset, most comprehensive one covering the entire globe. So you might want to try this one. Again, you can customize the color to whatever you want, whatever color you want. So you only need to change the style. We talk about more about this in the next topic about Map Libre, creating 3D maps. But for now, this just give you some flavor. How do you visualize large vector data set just with couple lines of code? Okay, so we have finished covering about the vector data set, from local data set, from data set in the cloud, and from those cloud optimized to this like large data set, like 100 gigabyte. And we can render it without any problem. So just like you can visualize Google Maps without any problem, you can visualize Google Earth without problem because you are not downloading the entire imagery archive to a computer. It's going to be infeasible. You are just requesting the tiles for your map area. If you zoom in, the resolution becomes much higher, but the area becomes smaller. The file size is still pretty small. If you zoom out, the map area becomes larger, but the resolution becomes coarser. So the file size that you need to request is still very tiny. So this is all pretty much the same similar for all the web map services. And that's why it's so powerful that we can visualize 100, almost 200 gigabyte file without any problem, because we are not downloading 200 gigabyte. We are just downloading a small piece of the data. Then what data to download is being handled by these applications. You can figure out which tile to download, which tile to use rather than the entire data set. So that's for vector data. Any questions? If not, let's continue with the raster data set. So either it's vector data, either it's raster data. So these are two primary GIS data format. So raster data, similarly, the raster data can be hosted locally, or the raster data can be hosted in the cloud. Just like you are watching any video, right? It can be coming from YouTube, or the video can be coming from your cell phone, or from your local desktop computer. So how to actually visualize this raster data set? And the first one we're going to cover here is using data from the cloud. So I'm going to show you here. This is called COT, okay? Cloud Optimized GeoTIFF. So if you want to learn more, you can, so basically it's just a GeoTIFF. The advantage is that they have added the so-called overviews, basically the image pyramid inside the data, so that you can request the data on the fly. So this file here, again, this is the HTTP URL, and you can click this one, you can download it. So again, I'm going to click, and I'm going to come here. Let's see how big is the file. So I'm going to click save. How big it is? 2.9 gigabyte. Okay, so this raster image is 2.9 gigabyte. I don't want to download it. You don't have to download. I can just use this function called add COG layer. Add COG layer means, okay, there's a file hosted in the cloud. It's a raster imagery. I want to render this one on my web. So just one line of code, passing the URL, and then you can see this one. If you zoom in, this is pretty high resolution. This is why it's 2.9 gigabyte. You can zoom all the way in. You can see all the trees. Right? Very nice imagery. So this one is from MaxR, previously called Digital Globe. So it's a satellite company that use satellite to acquire very high resolution data. So this is like centimeter level. So like maybe 40, 50 centimeter level. So it's super high resolution. And again, if you know the URL, you can just stream the data on the fly without having to download the data. So what you need is this function, add COG layer. Make sense? So previously, in the previous assignment, we have covered, right, how do you render the data using raster IO, using X-ray, using YL X-ray. So all those data sets that are provided to you is through HTTP URL. So right now, you can actually visualize any of those data sets. So let me show you. So if you go to, for example, a course website, right? If you go to maybe some of this assignment in here, and if it is a GeoTIFF, then we can do it easily. So, for example, this is a raster data set, for example. So I'm going to maybe open. It's going to ask you to download. I don't want to download it. So all you need to do, for example, in exercise 6, lab 6, right? I provide the raster file. You have to do the visualization and print out the static map. But we can actually visualize that. So I'm going to here, copy this URL, come back to here. And let me add a new line here, URL equal to this one. I can come out the other one. Same thing, just provide me the URL and let's see what it looks like. See? And the nice thing about it, you can zoom in, and zoom in. Zoom in. You can turn the layer on and off. You can change the opacity. Isn't it better than you use Raster IO? You have to worry about read the band and do the map, probably combine the RGB and then set up all the stuff here, right? Give me the URL, just add code layer, that's it. You don't have to worry about anything else. Everything is automatic. So super nice. So this is the way why you want to use like interactive visualization, because you can see the detail, you can zoom in, you can zoom out, you can change the opacity, and there's no messing around with the NumPy array, X array, RIL X array. It's just one line of code. That's it. So besides that, you can add multiple data layer. For example, you can add another data layer here. Let me comb out this one. Go back to the previous one, right? So this is the dataset before the wirefile. I can add another one. So I can add code layer. So you can add as many data layers as you want. So now I have two data layers. So this one here, the second one that I just added, this one is like after the wirefile. So you can see the changes in here, and you can turn the data layer on and off. This is post event, right? And you can change the opacity. And you can clearly see the changes. It's using the same methods. Just add cog layer, that's it. Just give me the URL and then just add a layer name, that's it. Super easy to do. So this is something that you might want to use for visualizing raster dataset. Even better, we can use the split map. So Leafmap has this called split map function that allows you to basically passing the left layer, the right layer. Just give me the URL, and then you can have a label. So the label going to show up here on the lower left corner, and another label showing up in the lower right corner. And then we can use this split window. So this one is also very popular. Zoom in, and you can drag your mouse somewhere. Then I can use this one to see the changes. Right? I can zoom in, I can zoom out. Okay, so try it out. You see, it's only pretty much 3 lines of code. Passing the URL, give me just the one on the left, the one on the right, and then just compare different data layers, right? You like it? Very easy, right? So this is, it can be used to compare any data set. So I can give you another example. I'm going to go to my datasets repo. Okay, and I'm going to change it to some other data set. So I have some raster data set here. Where is it? Where's somewhere here? The next one. Okay. So here I have some data set. For example, I have the lens set. I also have this one, Libya flooding. So July 1st and also September 13th. So assume that you found some data set in the cloud and you want to visualize that. Very simple. I can just come here, right click, okay, and then copy the link address, come back to my source code here. Then I can just add, for example, URL equal to the first one, and then enter URL 2 equal to, similarly, I'm going to copy this second URL, this one from September 13, copy the link, and then paste in here. Everything else will remain the same. So look at this. Just changing the URL. So now we are moving this to visualize 2 different data sets. And this is the new one. See this? You can zoom in. Right. So on the left side, this is before. This is after. Can you see the changes? It's pretty bad, the flooding. So this is just last year. And you can see how it geometrically changes. So how many lines of code? 1, 2, 3, 4, 5. 5 lines of code. And it's interactive. You can export the layer, you can export the map if needed. Again, you don't have to worry about, okay, open the data set, read the NumPy array, and then create the static map. This is all interactive, so it's so much easier. You don't have to handle all the low-level stuff. So this is about visualizing data in the cloud. In the next lecture, we're going to cover how to visualize data that's stored locally. It's going to be a little bit different, but certainly you want to use that because not all the data set that you want to use are available through HTTP URL. There's some files that is already locally, or some of the files that you generated after you have done some analysis. So we cover that in the next lecture. So that's all for today. I will see you in the next lecture.